All right. So we start with the main thing, probability 2. Probability 2. So, Akabasadam, what is probability?
Okay. Okay.
Yes.
Okay, please. Probability is the likelihood that an event
Oh,
may occur.
Oh, okay.
Okay, did you hear me?
Yes. Probability of an event in in a sample space is equal to the number of outcomes of the event over the sample space, which is the total possible outcome. So probability of event. So the last time we described what an event is. So if I write this, it means the P there represent probability, the E there represent the event. So we say probability of that event equal to the outcome over the sample space. The S there, we also said represent the sample space. That's the definition of probability. We'll take another definition of probability. So please quickly get this one. So we take the second one. The second definition there is probability is the likelihood of an event occurring or not occurring. That is all. The likelihood of an event occurring or not occurring. So if you perform an experiment, it is possible that an event will occur. If you flip a coin, it is possible that an event will occur. Do you know how to flip a coin? Sabita, do you know how to flip a coin? Sabita, I'm waiting for you.
Tablet is that?
Rosebud, do you know how to flip a coin?
Oh. Yes, sir.
Okay. People, I want everybody to pay attention here. Stop whatever you are doing, outside and concentrate here so that the lesson will move on smoothly for us. All right. Your hand is up, please. Sabita. So, the probability of an event D occurring is denoted by this expression here. The probability of an event D occurring is denoted by the expression that I've circled there, where the probability of D equal to the number of ways event D will occur divided by the number of ways that the sample space will also occur. So we also use the union symbol to represent the sample space, and that will give us the probability of D equal to number of D over the number of U. That is the formula for finding the probability of an event occurring. Now, let's move on with an example. We shall solve an example then. The first example is this. A box contains P red and Q green pencils. So the number of red pencils there is the small p, and the number of green pencils there is the small q. A pencil is drawn at random from the box. So if they are all in one box, find the probability that the pencil is red. So in this case, to find the probability that the pencil is red, we know it's going to give us the number of red pencils over the total number of pencils in that particular bag. So first, we say that number of red pencils, this one means number of red pencils equal to P, number of green pencils equal to Q, and then number of U, which is the sample space, or the total number of pencils in that particular box will be equal to P plus Q. So we also know that the probability that a red pencil is selected will give us the number of red pencils over the total number of pencils in that box. So this will now give us number of red, or probability that it is a red pencil will be equal to number of red pencils over the number of U. And this is equal to P. The P there represents the number of red pencils, and then the sample space is also P plus Q, which is the total number of pencils in the box. So that gives you the solution to the problem. Evelyn, do you have any problem there?
Please, can you come again?
So we are saying that probability is equal to the number of times an event occurs divided by the total possible outcomes. So over here, you are given the number of red pencils and then the number of green pencils. So the first thing you must do is to find the total number of pencils in the box. And the total number of pencils in the box will give you the sample space. So the total number of pencils in this our case will now give us what? P plus Q. The P plus Q there are numbers. The P there represents a number, the Q there represents a number. So if you want to find the probability that a red pencil is drawn, then we have the number of red pencils over the sample space. The number of red pencils will give you P, and then the sample space we know is also P plus Q. That's all. Rosebud, is that clear?
Yes, sir.
Okay. Also, Godwin, is that clear?
Yes, sir.
Okay.
Sir, I can't hear anything.
You can hear me. Can you hear now?
Yes. I
Okay.
guess, yes.
You can hear now, right? All right. Let's go to another example. Jakpasu Philip, have you finished copying this?
Yes,
Sir,
sir.
Yes.
sir,
Please raise your hand. I will call you.
sir,
Raise your hand. Yes, William.
sir. Sir, please, I just joined, so please, can you explain this example for me?
Okay. I'll take the second example. I'm sure you will get it better. Okay.
Okay, sir.
Yeah, I'll take the second example.
No.
Now, let's go to example number 2. If Q equal to
Thank God.
1, 2, 3, 4, 5, and 6, so that is the set. The set Q contains those elements. What is the probability that a number chosen from Q is, so the question will now follow. The first one, less than 4. We want to find the probability that a number chosen from this set Q is less than 4. The second one, the number chosen from Q is greater than 1. The third, the number chosen from Q is even number. The number chosen from Q is prime number. Please, there is no 48 there. Is prime number. This should not be there, please. The number chosen is a prime number. The next one. Okay, so that is all. Now, let's look at the solution. Write this, let's look at the solution. So, as usual, probability of an event occurring is equal to the number of times the event will occur over the sample space. That is the set of the total number of times that the event is likely to occur. Our solution is this. Event that the number is less than 4. So it means we need to look at all the numbers that are less than 4. If the number is less than 4, we put it in this set. So this is the event. The event that the number is less than 4 will give you 1, 2, 3. So to find the number of events here, the number of events here will give you how many numbers there are less than 4. We have 1, 2, and 3. So there are 3. Now, to find the probability that the number chosen is less than 4 is going to give us 3/6 because 3/6 because we have the sample space to be 6. The number of elements in the set, the number of numbers in the set there is 6. That is the sample space. And then the number of numbers which are less than 4 will also give you 3. So that will give you 3/6. So we have 1/2. Let me take the second one. The second one, we are finding the probability that the number is greater than 1. So if the number is greater than 1, then we write the event that the number is greater than 1. This one means event that the number is greater than 1. You don't write the full statement. How many numbers there are greater than 1? So we have 2, 3, 4, 5, and 6. If you count all these numbers, we have 1, 2, 3, 4, 5. 5 numbers in that set will be greater than 1. So your probability that the number is greater than 1 will now be equal to 5/6. That is the number of numbers greater than 1, and then the sample space is also 6. So we have 5/6. William, do you get this?
So please understand it.
Okay. Sabita, can you see the screen now?
Yes, sir.
Okay. Akaba, are you following the explanation there? Kaka Beauty, are you following the explanation there?
Yes, sir.
All right. Copy this. Let's move on. So everybody should try the third
Yes.
one. I will take the third one from one of you. One of you give us the answer to the third one. I will mention the names. Amu Junu, you will be giving us the answer to the third one. Yes, I can see some hands up. I'll call you later. Just hold on. Amu Junu, if you are done with the third one, you can give us your answer.
Please, I didn't see the question.
Didn't you copy the question?
Sir, please, no.
That's the question, please. Betty but Jonathan, give us the answer to the third one.
Sir, I just joined.
Jabado Grace, your hand is up. Evelyn, can you give us the answer?
Yes, sir. So the answer is 1/2.
Okay, that's your answer. Dansu Peace, give us your answer.
Sir, please add 1/2.
Okay. Eunice.
Sir, please, I had 1/2.
All right, so let's check the solution and see if the answers are all the same. So C, even numbers. So the number of even numbers there, we have 2, 4, and 6. So 3. Probability that it is an even number will now be equal to 3/6. So 1/2. That's right. Give us the answer to the next one, Tula.
Let me see the question.
No, I don't think we can go back there. I'm sure you were not paying attention. Even number.
Say no, please, my network.
Okay, I'll show it to you. Apedo root.
Sir, please add 1/2.
Okay. Please. Petibo Jonathan Akaba said you should mute yourselves, please.
Okay.
All right. Let's check the answer to the next one. So prime, probability that the number is prime. We have 2, 3, and 5. What is a prime number? Eunice, your hand is up. Can you answer that? What is a prime number?
Sir, please, a prime number is a number that has 2 factors, one and the number itself.
So give me the first 3 prime numbers.
Sir, please, there are 2, 3, and 5.
All right. So in this set, we have the same
The
2,
three.
3, and 5. So let's go to the next question. Okay, we have some information, the notation. Now, in probability, if A is an event, that is A is any event, then probability of A is given as this. If I write this, this means the probability that A will occur. So anytime you see an expression in this form, it means that the probability of that event occurring. So this is the probability of A occurring. Again, if I have this, the A, and then there is a bar on top of the A, this means the probability that A will not occur. So if you want to find the probability that the event A will not occur, you put a bar on top of A. This is called, these are some of the notations we use in probability. Good. Write that quickly, please. Okay. Laws of probability. So there are some principles guiding probability, some rules when you are solving questions relating to probability. And let's look at some of those conditions. And you need to know those conditions. So these conditions will even help you know whether what you are doing is wrong or is correct. The first law of probability here, 1. The probability that an event A will occur lies between 0 and 1 inclusive. 0 and 1 inclusive means that the probability of any event, any number occurring should be between 0 and 1, which means that if you are solving questions relating to probability, your answer should never be less than 0. You cannot get your answer to be negative. At the same time, your answer can also not be more than 1. So your answer is always from 0 up to 1. Any number within 0 and 1. And 0 and 1 is also inclusive. Is that clear, Mensa? Now, the second one. The probability that the sample space will occur is 1. The probability that the sample space will occur is 1. That is this. So the sample space there, we are using the S. So probability that S will occur equal to 1. What it means is that, for example, if you have like the previous example we had, the Q, where we had 6 members in that set, probability, when they ask you the probability that the sample space will occur is going to be the number of events in that set, which is 6, over the sample space, which is 6. So 6 over 6 will give you 1. So we say that the probability that a particular set will occur is equal to 1. Sorry, get these two down before we move on. They are 4. We shall take all the 4, then we apply them to solve some questions. Probability that an event A will occur lies between 0 and 1 inclusive. So this one, probability of A is greater or equal to 0. And then the probability of A is also at the same time less or equal to 1. The probability that the sample space will occur is also 1. And that is what we have over on the screen. The third one, probability that empty set, you know, this symbol there represents empty set. This is an empty set. Probability that empty set will occur is also 0. which means if you perform an experiment, you should be expecting an outcome. If you flip a coin, you know, a coin, we said it has two faces. Definitely one of the faces will show up, or you will see one of the faces lying flat. There is no way you flip a coin and you will not see any of the faces. Okay, so probability that nothing will show, empty set there means that nothing will show is 0. There will be something there where this symbol is the null set. The fourth one, if the probability that an event A will occur is denoted by this. So this is the probability that an event A will occur. That gives us probability of A occurring equal to X. Then the probability that the event A will not occur is also denoted by this. This is the probability that event A will not occur, and that will be equal to 1 minus X. 1 minus X because, okay, I'll explain that. Probability that the event A will occur plus the probability that the event A will not occur should be equal to 1. Probability that this one will occur, and then probability that this particular one will also not occur, the same event will not occur. If you put the two together, it must give you 1. So if you continue with the substitution, we know that probability of A occurring is denoted or is given by X, and probability of A not occurring is also given by 1 minus X. So in place of the probability of A and probability of A not occurring, we put in the X and then 1 minus X. That will be equal to 1. Let's try that and see. So this will be equal to, that is, so we have probability of A, we know that is equal to the first X, that is this X here. And then probability of A not occurring is also given by 1 minus X. So you will see X minus X will give us 0. So the X is gone. So you are now left with what? Your 1. That is why we say probability of an event A occurring plus the probability of an event A not occurring is equal to 1. This one. William, is that clear?
Yes, sir.
Okay, so copy that, let's move on. I'm a mature courage. Have you finished copying?
Yes, sir.
Okay. Apeku Emanuela, have you finished copying?
Yes, sir.
Dansu Peace, have you finished?
Yes, sir.
All right. Let's move on to the next slide. Example 1. A number is chosen at random from the integers 5 to 25 inclusive. You see, 5 to 25, which means that 5 and then the 25 itself are all inclusive. Find the probability that the number is A, a multiple of 3, B, an even number, C, prime number, D, an odd number, E, greater than 15, and then our F less than 20. I want everybody to try the first one. A multiple of 3. We are finding the probability that the number chosen is a multiple of 3. Setrafia enseño. Seke Benoni. Your answer. Dokas Wolali. Okay. Yes, Dokas. Let's move on. So our solution is this. Okay, the last question there, between 7 and 25. Please add it. Between 7 and 25. Solution to the first one. Now, first, we need to write the sample space. So let's get all the events there. So we are referring to all integers from 5 to 25. And that will give us 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, up to 25. Now, if you count all the numbers there from 5 to 25, it gives us 21. So your sample space is equal to 21. The first one, we are finding the probability that the number is a multiple of 3. If the number is a multiple of 3, then we are referring to all the multiples of 3 in the set S. All the numbers which are multiples of 3 in the set S. So if you look into the set S, you will see that now 6 here is a multiple of 3, 9 is a multiple of 3, 12 a multiple of 3, 15, we also have 18, 21, and then 24. So that forms this set event, that a multiple of 3, and the number of events there is 7. So probability that it is a multiple of 3 is going to be 7 over the sample space. And we know the sample space as 21. So probability that the number is a multiple of 3 will now give us the 7 over the 21. So let's see. 7 over 21. And if you simplify this, it gives us 1 over 3. Dan, so do you understand that?
Yes, sir.
Yes, sir.
All right. Apedo Ruth, do you understand that?
Yes, sir.
All right. Copy that quickly. Okay, let's continue to the next one. Oku Eunice, your hand is up. The next question, we want to find the probability that the number is even, and probability that the number is even will be, so we need to select all the even numbers from the set. And all the even numbers, we have 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. So let's see, the probability that the number is even will now be equal to 10 over 21, because if you count them from 6 up to 24, we have 10. And that will be over the 21. Peace. Your hand is up.
Sir, please, I had 2 over 5.
Is it a B, the probability that the number chosen is an even number?
Yes, sir.
Oh, okay. How did you do it?
Sir, please, the number of S is 21. So the probability that the number is even is 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And I counted all the numbers and I had 10. So I'll divide 10 over the number of sample, which is 10 over 24, 25. And I divided it and I had 2 over 5.
Oh, okay. This is where you made some small mistake. It's not over 25. You know, the total number of elements there is 21, right? That is 5, 6, 7, 8, 9, 10, 11, 12.
Yes,
If you count
sir.
all of
Sorry.
them, it gives you 21. So it will be 10 over the 21. Okay, good. So you continue with the rest of the questions there. Okay, William, your hand is up.
Sir, sir, please, when I solved it, I had 0.5.
0.5 is what? What is 0.5?
Sir, the question you are solving,
Mm-hmm.
like I had 10 over 21.
Yes. So it's the same thing. Okay.
Yeah.
Yeah. Thank you. But Eunice.
Yes.
Sir, please, I wanted to give the answer for the third one.
Okay, what's your answer?
Sir, please, the third one, I got 1 over 3.
All right. So just keep your answers. Go and practice the third one, and then you compare your answers later. Okay. So just go and solve those ones. We go to example number 2. In a class of 27 boys and 18 girls, what is the probability that a student selected at random is A, a boy, and then B, a girl? Everybody should try the first one.
Got 18 over 45.
Eunice, please come again.
Sir, please, the A, I got 27 over 45. And then the B, I got 18 over 45.
Okay. Mensa Mavis, your answer. Tamaklo Shelga, your answer.
Sir, A, I had 3 over 5. And B, I had 2 over 5.
Okay. Michael Apenyo.
So please, A, I had 3 over 5, and then B, I had 2 over 5.
All right, thank you. So yes, the rest of you, I'll call you to answer the next question. Yes, so let's look at the suggested solution. Now we know that the sample space is going to be the number of boys plus the number of girls. That will give you the 45. Probability that it is a boy will give us the number of boys over the total number of students. So we have 27 over 45. And your final answer should be 3 over 5. You know, at all times, you need to simplify your answer. The next one, probability that it is a girl, will also give us the number of girls over the total number of students. The number of girls there is 18 over 45, and that gives us 2 over 5. So that's the suggested solution. So I expect you to get either 3 over 5 and then 2 over 5. Your answer should not be 27 on 45, 18 on 45. No. So correct that. Let's move on. Jabado Grace, your hand is up.
Sir, please, can you change into decimals?
Yes, but I've always been saying that if you are not asked to leave your answer to a certain number of decimal places, just simplify it and leave it in this way. Are you okay? But if you convert your answer to a decimal, it's still not wrong, but that may be dangerous sometimes. Okay, let's move to the next slide, example number 3. A bag contains 60 identical balls, of which 32 are white and the rest are yellow. Find the probability of picking at random a yellow ball from the bag. Try that quickly, let's see. Daniel, Ewoyi.
Sir, I had 7 on 15.
Okay, that's your answer. Michael Apenyo.
So 7 on 15.
Okay, Chantal.
7 on 15, sir.
Yeah. Tiola.
So I had 7 over 15.
Okay, the rest of you should wait. Let's check the suggested solution. They are all giving the same answer. Let's compare our solutions. So now with this, we know that the total number of balls you have in the bag is 60, and then the number of white balls there is 32. The number of yellow balls we also have. So to find the number of yellow balls is going to be the total number of balls minus the number of white balls, and that will give you 60 minus the 32. So we have 28. So probability of selecting or picking a yellow ball at random will be 28 over 60, and that gives you 7 on 15. Yes, you are all right. Please correct it quickly. Let's move on, those who couldn't get it. All right, let's move to the next slide. Example number 4. So we have this example. A fair coin is tossed twice. So we learned about writing the sample space whenever a fair coin is tossed twice. We said if a fair coin is tossed twice, it's the same as tossing 2 coins once. So let's see what is going to happen here. Write down the set of possible outcomes. What is the probability of obtaining I exactly 2 heads, which means that the 2 outcomes must all be head. Copy that. Let me give you what is on the next slide. We are going to the next slide. No head, that's we are finding the probability that no head. And then the next one, at least one head, a head and a tail, at most one head. Let's look at the suggested solution. So our solution is this. So if you toss a coin 2 times, we have the result. This is the first, if you toss the first time, if you toss the second time, will give you head, tail, head, tail. Now, this one will be the event, head, head, that's this, and then this from coin A, this results from coin B. So we have head, head, this result from coin A, and then mapping to this result will also give us head, tail. The same way, if you take this tail and the first head from B will give us tail head, this tail, and then this tail will also give you tail, tail. So the sample space is 4. The events are head, 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 tail, tail, head, and tail, tail. So now we want to find the probability. This is the set of possible outcomes for the first one. To find the probability that you obtained exactly 2 heads, which means that the 2 results you will see will all be head. And that is going to give us this. Let me move to that slide. Exactly 2 heads will be equal to 1/4, and that is going to give you head, head. And the number of events that will have head, head is 1. So we have 1/4. The second one, we want to find the probability that there is no head. And if you check the outcomes, only one of them having tail, tail. We don't have any head over there. So the number of events there is 1 over the sample space, which is 4. The third one, probability that at least one head means 1 head and above. So we have head, 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 tail, tail, head. They all have 1 head or more. So they are 3. And the number of events having a head or more is going to give us 3. And that probability that at least 1 head will be equal to 3/4. The next one, probability of obtaining a head and a tail, which means in the 2 results, one of them must show head, one of them must also show tail, or one of them must be a tail and the other must be a head, or you must have a head and a tail. And if you check, we have head, head, and tail, head. So the event there is also 2. So we have 2 over the sample space, which is 4, and that will give us 1/2. Any problem with this? William?
Sir.
Any problem? Tiola, any problem?
No, sir.
Okay. Apedo Root, your hand is up.
Sir, please, I don't understand.
Akiti Pearl, your hand is up.
Sir, please, when
Come again, please. I can't hear you.
solve it, are you going to draw the diagram to indicate the Sir, please, if the answers to solve this question, are you going
Yes.
to draw the
Okay.
There.
All right. Let
Please,
me
when going to draw the diagram to indicate okay.
Akitipe, let me answer your question. So you are asking whether we have to draw the table there. Now, if for this we have only few events, you can easily write the possible outcomes. So you may not need a table. But when you have several events, you need to write. For example, you are to toss a coin 3 times. You should write a set of possible outcomes. It will be quite cumbersome if you don't use a table. But in this case, it's appropriate you use either you write it by default or you use a table. It may not be compulsory that you use the table. Anyhow you can do it to get all the events is allowed. I hope I've answered you.
Yes, sir.
All right,
Thank
thank
you.
you. So that is it. The next one, who can give me the answer to the last question? At most. At most. Okay. So the last one, I thought we have another question there. Okay, maybe that is all. William.
Sir, sir, please, I had 1 on 4.
Okay, that's your answer. Chantal.
So please 1 on 2.
Okay, that's your answer. Um, I will leave that for you to go and try. So I will not comment on the final answer. Another example, 3 fair coins. So Sabita, we are coming to your question. 3 fair coins are tossed once. Write down the set of possible outcomes. You know, some of these questions, if you don't use a table, you are likely to miss one of the events. And that will lead all your solutions to a wrong answer. So we have to use a table. What is the probability of obtaining exactly 2 heads? Write this. Let's move on to the next slide. The probability of obtaining exactly 2 heads. The next one, no tail. That's the I, not more than 1 head. IV, at least a head. At least, that is at least 1 head. If nothing at all, if you don't get cry, if nothing at all, you must have 1 head. Try the first one. Everybody should try the first one. Get the sample space, then let's move on. Yes, Eunice.
Sir, please the sample space.
Yes. How many, what will be your
Heads.
sample space? How many events do you have?
Sir, please, I have 8 events.
8. All right. So you keep it for now. So let's see what we have here. This will be your result. So 3 coins, it's quite complicated. So I have to toss 2 coins once and then toss the third coin. So if I toss the 2 coins, it's going to give me, as usual, 2 coins will give me head, 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 tail, tail, head, and then the tail, tail here. Sorry, let me erase this so that you can see it clearly. So we have the tail, tail. And if I should toss the remaining coin, the 1 coin, it will also give me the head and then the tail. So I need 1 here, 1 here, 1 here, 1 here. Now, this and this, this and this will give me head, head, head. This and this one will also give me head, head, tail. So if you go through the process, this one and then the first head here will also give me head, tail, head. You go through the same process, you are going to get the sample space to be 8, so that your sample space head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, 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 equal to H. That is your sample space. We move to the B part, where we are to find the probability of obtaining exactly the first one, 2 heads. The first one is exactly 2 heads. So for exactly 2 heads, we have this. Three over 8. So if you check the event there, you will see that 3 of the event will have, we are going to have head, head, tail, tail, head, 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 tail, head. So this will give us exactly 2 heads. So we have 3 over 8. The next will also give us probability that no tail. If no tail, it means that all the results, all the 3 coins will turn head. So we have 1 over 8, because only one of the event is going to give us a result without a tail. The next is also probability that it is not more than 1 head. If it is not more than 1 head, then it is also possible that you will not have any head at all. Probability that not more than 1 head, meaning it's possible you will get no head. So that will give us tail, tail, tail. Then the other ones will also add up. So that will give us 4 over 8, 1 over 2. Probability that not more than 1 head, which means you cannot exceed 1 head. The highest number of heads you have is 1. And it is also possible that you wouldn't have any head at all. So we have 4 over 8. That gives us 1 over 2. Sabita, are you following the explanation?
Yes, sir.
Okay. Agbemo William, are you following?
Yes, sir.
Amanyo Jessica, are you there?
Yes, sir.
All right. Emmanuel Edogake, are you getting it?
Yes, sir.
All right. Then the last one, probability that at least a head will give us 7 over 8. At least a head. What it means is that if nothing at all, you should have 1 head. So you can have 1 head, 2 heads, and 3 heads. At least, if nothing at all, it is like you are going to write end of term exams, and your parent tells you, hey, next term, if nothing at all, make sure you pass commas. It means if nothing at all, you shouldn't get F9. You should get a pass. So you can get E8, you can get the D7, C6, C5, any of those. but you cannot get F9. At least one head means one head and above. That's the explanation. And this is also the same as 1 minus the probability that no head. 1 minus the probability that no head, which will also give you 7/8. We know probability of not having any head sorry, yes, it's 1/8. Probability of not having any head is 1/8. So at least one head will give us 1 minus the probability of having no head, which is 1 minus 7, 1 minus 1/8. So that will give us 7/8. So the same thing. Apedo Root, your hand is up.
Sir, please, I don't understand.
Probability of obtaining at least one head means one head and above. Are you okay? So if one head and above, then let me take you to the diagram. One head and above. If nothing at all, there must be one head. Are you okay? So that is going to give us this event. You will have, you see, there is one head here, one head here, at most one head. Oh, at least one head here, one head here, one head at least. So it's here. Another head here, we have 2, we have 3. 1, 2, 3, 4, 5, 6, 7. That gives us 7/8. The events there are 7. And I'm saying that at least one head is the same as the probability that no, 1 minus the probability that no head. At least one head is the same as 1 minus the probability that no head. And probability that the event, there wouldn't be any head, is going to give us 1/8. That is tail, tail, tail. So we have 1/8. So 1 minus 1/8 will also give us 7/8. Ruth, did you get that?
Yeah.
Okay, I saw another hand up. Another hand is there. Who? Yes, Sadem.
Sir, please, the I and I don't understand.
What is it saying?
The probability that you get exactly 2 heads,
Okay.
and the probability that you get no tail.
Okay, let's do probability that exactly 2 heads. Now, exactly 2 heads means you shouldn't go beyond 2 heads, meaning after the event, you must have two heads in the result. So the event, the result there that will give us exactly 2 heads is going to give us, let me clean this. So exactly 2 heads. You see, if you come here, you see we have head, head, tail. That is exactly 2 heads, meaning 2 heads and 1 tail. But our focus is on the number of heads. If you come here, we have head, tail, head. So we have exactly 2 heads in this result. If you come here, we have only 1 head, so this is not inclusive. If you come here, we have tail, head, head. We have our 2 heads here. And none of the events there will give you exactly 2 heads again. So the probability of obtaining exactly 2 heads will be the number of events having 2 heads over the sample space. So the number of events there, we have 1, 2, and then 3. That is 1, this is 1, this is the second one, and then this is also the third one. So it's going to be 3 over 8. Did you get it now, Sadam?
Yes, sir.
And you said the next one is what?
So the II, probability that you get no tail.
You will get what?
No tail.
No tail, which means that there wouldn't be any tail. If you have 3 coins and all of them, none of them will be tail, meaning they are all going to show head, head. Are you okay? Head, head, head. And that will be 1 over 8. No tail means that they are all heads. So we are only going to have this particular event. That is the one giving you the head, head, head. You see, there is no tail in this particular event. So we have 1 over 8. Are you okay?
Yes, sir.
All right. Who is also having a challenge? So that's the solution there. Copy that. Okay. So we can now go to the next slide. So we have another example here. 2 fair dice. 2 fair dice, A and B. The last time I introduced you to a die, I showed you a die, the Ludo. If you want to, those who play the Ludo game, we have the die. It is always a square. It has equal faces and it has 6 faces. So numbered 1 to 6, yes. So the faces are numbered 1 up to 6. So you see dots. Sometimes you see a dot in one of the faces, 2 dots, which means 2, 3 dots means 3, 4 dots. So somebody will call 4 Miludu, 3 Miludu, 5 Miludu, 6 Miludu, in that order. Now, they are numbered 1 to 6, and this is thrown together. So construct a table showing all the equally likely outcome. From your table, list the pair of numbers on the 2 dice for which the sum is I, 5, I, 10, I, more than 10, IV, at least 10. So this is the last example for the day. Let's look at, or maybe I'll just leave this for you to go and then try this example. Yes, I think I should do that. So please, each and every one of you should go and try this, and then now when we meet again next time, we shall look at